Okay, so let's say we can express each side as a power with the same base and set exponents equal to each other and then solve. So this, let me write it next. Exponential and logarithmic. Okay. We want to put each side as a power with the same base and set the exponents equal to each other and then solve. So solve 3 to the x equals 81. 3 to the x equals 81 is 9 times 9, which is 3 times 3 times 3 times 3. So 3 to the 4th. So I can see that x equals 4. Solve 1/2 to the power that is 6 minus x equals 2. I will try to rewrite this with the base being 1/2, the base, the big number. So 1/2 to the 6 minus x equals 1/2 to the minus 1. Now I have the same base, so I can ignore those. And focus on my 6 minus x equals minus 1. I'm setting my exponents equal to each other and then solve it. So minus 6, I get into the streets. Minus x equals minus 7. So x equals 7. Mm. 2 to the x squared plus 4x equals 1/8. Now 1/8 is really 2 cubed, so I could write 1/2 cubed. And then if I didn't want this to be a fraction anymore, I would make my exponent negative, which will bring it to the top. So it equals 2 to the minus 3. So I'll set those equal to each other with the same base of 2. Now I can ignore the base and set the same. And I have x squared plus 4x equals minus 3. Oh my goodness, this looks like stuff we have done before. How strange. So I bring my minus 3 to the other side. Equals 0. I can solve by factoring. I can solve by quadratic formula, square root method. Go back to factoring because it's my first love. So x squared plus 4x plus 3 equals 0. Looking for two numbers that multiply to give me 3, but add up to give me 4. Easy. You're very welcome. 3 and 1. Both pluses. Now I set each of those parts equal to 0. X plus 1 equals 0. One of the answers is -1. How do I know I have more than one answer? Because I have this exponent tells me how many answers I'm going to have. X plus 3 equals 0. X equals -3. So one of my answers is -3, and one is -1. We take the logarithm of each side. Before we had each side and we were setting exponents equal to each other. Take the log of each side and find the solution to the nearest thousand. This will require a calculator. Solve e to the x equals 7. So when you see e, that's kind of like when you saw the negative inside of the radical sign and the I just shows up. When you see e, the natural log just shows up. Natural log of e to the x equals natural log of 7. Whatever I do to one side, I do to the other side. So I have x, now I have, they're both the natural log. So I have x equals the natural log of 7. Bing, 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 bing in the calculator. 1.946. And the calculator I could show you on the screen. Okay, so 135 minus 4.7 to the x equals 0. So 135 minus 4.7 to the x equals 0. Just remove the parentheses, bracket. Minus 4.7 x equals 135. Minus 135. Minus 135. So 4.7x, I'm just taking away the minus sign. Equals 135. Natural log of 4.7 to the x equals natural log of 135. This x will come in front of these things. So x to the natural log of 4.7 equals natural log of 135. I divide away because I want to get x by itself. Divide this side by natural log of 4.7. And divide this side by natural log of 4.7. Calculator, 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 magic calculator. 3.1696. You solve log base 5 of x equals 7. So base to the exponent equals answer. Base to the exponent equals answer. 5 times itself 7 times. 1, 2. You have a calculator. 6. This is 25. 25 times 25 is 625. 25 times 5 is 125. Calculator, 125 times 625. 78,125. X equals 78,125. So Ln of x equals -2. Natural log, that's this, log base e of x equals -2. Base to the exponent equals x. X equals e to the -2. We can look like that. I wonder if we could put e in the bottom. Oh, that's kind of weird. Not sure. We'll solve log base 6 of x plus 5 plus log base 6 of x equals 2. If these things are together with a plus with the same base, then they can be multiplied. So I'm going to write it in the multiplication form. Log base 6 of x times x plus 5 equals 2. Base times exponent equals answer. So base is 6 times exponent equals answer. So 36 equals x squared plus 5x. So minus 36, minus 36. So I'm going to switch sides. X squared plus 5x minus 36 equals 0. Back to factoring. I'm looking for two numbers that multiply to give me 36, but have a difference of 5. X and x for 36, I have 12 times 3, 2 times 18, 6 times 6, 4 times 9, 36 times 1. So which of these factors have a difference of 1? Oh, sorry, of 5. When you take them minus each other, which of them have a difference of 5? Okay, so here's our winners, 4 and 9. So 4 and 9, they multiply each other to be minus, but I need the larger factor to be a plus. So in front of the 9, I'll put the plus. Now set them equal to 0. X minus 4 equals 0. I'll set the other one equal to 0. X plus 9 equals 0. X equals -9. You can't have a log of a negative number, so this is not gonna be an option for us. Okay, you can't have a log of a negative number. So our only answer would be X equals 4.